Hey everyone, and welcome. We're about to jump right into the heart of artificial intelligence. But look, this is not going to be your typical history lesson. We are diving deep into the core intellectual battles, the big debates, the brilliant disagreements that are shaping the future of AI, and maybe even how we understand our own minds. All right, so here's our game plan. We're going to start with the big picture, the search for intelligence itself. Then we'll rewind a bit to look at some old debates that are still shaping our new technology. We'll compare different ways to even approach discovery, and then get into the nitty-gritty of building artificial brains. After that, we'll explore AI's new role as a scientific partner. And finally, we'll talk about the future, which is very much still unwritten. Okay, let's set the stage. The story of AI isn't just about code and computers. At its core, it's a story about a fundamental disagreement on what intelligence even means. And this is not just some academic squabble, believe me. The stakes are incredibly high for all of us. So, the most important thing to get is that understanding AI isn't about memorizing a timeline of inventions. It's about understanding the constant tension between these powerful, competing ideas about what intelligence is. And that brings us to our first major battleground. To really get what's happening right now with AI, we've got to rewind the clock. I mean, way back to the very beginning, to the exact moment when two completely different ideas about how to build a mind were born. So check this out. Right at the dawn of AI, in the late 1950s, you have the term artificial intelligence get coined. And then bam, just 1 year after another, two totally different approaches pop up. This created a massive split, a rivalry that, in a lot of ways, is still playing out today. And this slide just lays it out perfectly. On one side, you had symbolic AI. The folks in this camp believed you could basically program intelligence with logic, with explicit rules and symbols. Then you had the other camp, probabilistic AI. And they were like, no, you've got it all wrong. Intelligence isn't programmed. It has to be learned from data by spotting patterns, kind of like how our brains do. And do you want to know how deep this division ran? Just listen to this quote from Marvin Minsky, who was an absolute giant in the symbolic camp. You can feel his frustration. He's essentially saying that everyone's obsession with neural networks was starving what he saw as the truly hard work of AI, which was figuring out common sense. Now, this debate wasn't just theoretical. It had real-world consequences, shaping who got funding and how research was even organized. So let's look at two completely different models for how scientific discovery happens, because it really influenced the kind of AI that got built. So first up, you have the legendary Bell Labs. I mean, this place was an absolute invention factory, but it was highly structured, very top-down. Research was always tied to practical needs. Someone needed something built, and the research was aimed at that goal. It was the perfect environment for that engineering-heavy, symbolic view of AI to really grow. But fast forward to today, and wow, the world of breakthrough science looks totally different. It's often more of an underground scene. If you're a young researcher with a wild idea, you have to find your tribe, piece together weird funding, and build your own little community. It's in that kind of chaotic, bottom-up world that something experimental like neural networks could quietly grow for years. Okay, so enough about philosophy and funding for a second. Let's get down to the nuts and bolts. How are people actually trying to build these artificial minds today? What's going on under the hood? One of the holy grails here is a concept called compositionality. It sounds really academic, but it's something you and I do every single second. It's that amazing human trick of taking a handful of basic building blocks, like words, and combining them in infinite new ways to create and understand new meanings. And this table just shows you how wildly different the two main approaches are right now. On one side, you have transformers, the engines behind today's large language models. They work with macro-level tensor operations, which is a fancy way of saying they do massive, high-level math. They're basically incredibly powerful statistical engines. But on the other side, you've got these brain-inspired models. They work at the micro level, trying to actually simulate the messy physical reality of individual neurons and synapses, how their connections change and strengthen. That's called synaptic state plasticity. It's really the difference between an elegant calculator and a simulated living system. So as these AIs get more and more powerful, something really new is happening. They're no longer just the subject of the research. Scientists are actually starting to use them as collaborators, as partners in discovery. And that shift comes with some incredible promise, but also some pretty serious risk. The promise is something people are calling vibe coding, and I love that term. It's this almost magical ability to have a complex scientific idea, a vibe, and have an AI instantly translate that into working code. It has the potential to just massively speed up the pace of research. But, and there's always a but, right? Here is the danger. This PhD comic just nails it. It's the trap of bug hacking. It's when you form a hypothesis you really like, you get the AI to write the code, and what do you know? The code confirms it. So you stop checking. You start subconsciously guiding your tools to give you the answer you want, not the one that's actually true. It's confirmation bias, but supercharged with AI. And all of this brings up a huge, really practical problem: sustainability. I mean, if every little lab is using AI to whip up custom, one-off code for their specific project, who's going to maintain all of it? Who has the time and money to make sure it's reliable, and that other scientists can use it down the line? It's a major challenge. So, after all these debates, all these different visions and battlegrounds, where does all this leave us? Well, the future of AI probably isn't about one of these approaches just winning and taking home the trophy. The real path forward, the one that's going to lead to the biggest breakthroughs, will almost certainly come from bridging these divides. We're talking about hybrid systems, ones that can combine the clean logic of symbolic AI with the incredible pattern matching of deep learning, and maybe even the physical grounding of these new brain-inspired models. And this really forces us all to ask a huge, fundamental question about the goal here. Are we just building a better tool, a fancier calculator to solve problems for us? Or are we actually trying to build a partner, a new kind of mind to think with us? And maybe the most profound thing in all of this is that in our quest to build an artificial mind, what we're really doing is holding up a mirror to ourselves. This whole incredible journey is forcing us to re-examine what it means to be intelligent, to be creative, to be human. The future is unwritten, and believe me, this great debate is far from over.